OffLecture. Learn beyond class.
Hello students and welcome to OffLecture. Now we are moving towards the topic 3 in fractions, which is fractions on the number line. A number line is a straight line on which we show the exact position of fractions, and let's see how we can place and compare fractions on the number line. So in the topic 3, we will be going towards the three things. First is marking fractions, proper fractions on the number line, marking improper and the mixed fractions on the number line, and using the number line to compare the values. Okay, so let's start with the first topic, that is marking proper fractions on the number line. First of all, we will draw a line. As you can see, we have drawn a line, and we can also draw one line by ourselves also, starting from 0 and ending till 1. A proper fraction lies between them. For example, we have a proper fraction, let's say 2 by 5. We know a proper fraction will be always less than 1. So it will range between 0 to 1. And since it is positive, it will be always greater than 0 but less than 1. Okay. Now what we will be doing is that we will break 0 and 1 into equal gaps equal to the denominator. For example, let's say we have 2 by 5. So in the number line, what we have done is we have created 5 equal gaps in between 0 and 1. 1, 2, 3, and 4. So we have one gap here, one gap here, one gap here, one gap here, and one gap here. All are the equal sets of gap. Then count from 0 as many gaps as the numerator. So let's suppose this is 2 by 5. So we have created 5 equal gaps, and now we will count from 0 how many gaps we have in the numerator. So we will jump from 0 to 1, and then from this to this. So we will reach at this point for 2 by 5. Okay. So this is where your fraction will lie on the number line. And why we are creating equal gaps? This may be the question. But if you have watched the previous lesson, you will be very much sure about this, because fraction always means the equal parts. Fraction always mean equal parts. If we have equal parts, then we can create the fractions. And if the gaps again will be, if there is no equal parts, or if the gaps were uneven, the fraction would land definitely in the wrong place. Okay. So what are the simple steps for placing a proper fraction on the line is, first we create a number line from 0 to 1. Cut them into bottom parts, that is we will cut them into number of parts which denotes denominator, which is coming in the denominator. Then we will count the top gaps, that is we will count the numerator gaps, and we will land on that number. Wherever we land, that will be our representation of fraction on that number line. Okay. Let's do an example on it. For example, let's say we have to place 3 by 4. So for placing 3 by 4, what will be our step-by-step solution? First, we will see that denominator is 4 in 3 by 4 or 3 over 4. So we will create 4 equal gaps between 0 and 1. So this is 0 and this is 1. This is our number line representation. So we will create 4 equal gaps. To create 4 equal gaps, we need 3 intersections or 3 bisections of it. So we will create this 1, 2 and 3. So once we create this, what we will do this, we will label them with 1 by 4 because this is first part. This is second part of that, which is 2 by 4. This is third part of that, which is 3 by 4. Now, since in numerator we have 3, so we will jump 3 steps. So we will count 3 steps. First, second, and third. So we are landing to this position. It means that we will put a dot on this third mark, and this is where our 3 by 4 fraction will sit on the number line. Okay. Now you guys have to try it on a 0 to 1 line split into 6 equal parts. Where would you place 5 by 6? That is how many gaps from 0. Okay. So the hint is very simple. First of all, you have to divide your number line 0 to 1 equals to number of gaps equals to denominator, and then you have to count numerator gaps from 0. So if we see the answer for this, just a second. If we see the answer for this, since the fraction is 5 by 6, so we will create this many number of gaps, that is 6 equal parts. We will divide our number line into 6 equal parts. 0 to 1, so this will be 1 by 6, this will be 2 by 6, this will be 3 by 6, that will be 4 by 6, this will be 5 by 6. Okay. Then we will jump, or we will count the gaps as many as numerator. So we will count 5 steps. 5 count will be there. First, second, third, fourth, and fifth. As we land on this, so this will be our representation of 5 by 6 from in the number line. Okay. I hope this is clear to everyone. Now let's move to the next part, which is representing improper and the mixed fractions on the number line. So as you know, what is improper fraction, where the numerator is greater than denominator, and their value is greater than or equals to 1. Okay, their value is greater than or equals to 1. So as you can see, this will go on the number line past 1. Okay, so this will go past 1. So you have to extend your number line based on up to 2, 3, and like this. We will keep the gaps the same size in every hole. That is, the size will always be same. There will be equal gaps that we have to keep in every hole. So let's try to understand how we can, let's say we have to plot, or we have to put 7 over 6 on the number line. So how we will be doing that? First of all, we know that this is an improper fraction. This is an improper fraction. So what we will do is we will extend it past 1. So what we will do is we will create from 0 to 1 first. Okay, this is 0, this is 1, and since again we will see the denominator, so denominator is 6, so we will create 6 equal parts between 0 to 1. So 1, 2, 3, 4, and 5. So 1 part, second part, third part, fourth part, fifth part, and sixth part. So if we write the labels on this, this will be 0 by 6, this will be 1 by 6, this will be 2 by 6, this will be 3 by 6, this will be 4 by 6, this will be 5 by 6, and then this will be 6 by 6. Okay. If we create one more equal part, this will be 7 by 6, again one more part, 8 by 6, again one more part, 9 by 6, again one more part, 10 by 6, again one more part, 11 by 6, and then once again one more part 12 by 6, which is nothing but 2. So what we have done is we have moved past 1. We have moved past 1. Now again we will count the number of gaps that is present in the numerator. So this is first gap, second gap, third, fourth, fifth, sixth, and seventh. And we will land here. So this will be the representation of 7 by 6 on the number line. Okay. And remember a mixed number. Now we have understood that how improper fraction will come on the number line. Let's suppose we have a mixed fraction which is 1 is to 1 by 6. Okay, this is one whole part and this is the extra proper fraction. So if we write 1 plus 1 by 6, it will come as 1 plus 1 by 6. So this will become 7 by 6 only. So both will land on the same point on the number line. Okay. Now let's do one example where we have to place 5 by 3. So 5 by 3, how we will do it? Let's do step by step. We will divide in the gaps of 3 because denominator is 3. So we will create 3 equal parts first from 0 to 1, and from 1 to 2 we will again create 3 equal parts. So we will get 0 by 3, 1 by 3, 2 by 3, 3 by 3, then 4 by 3, 5 by 3, and then 6 by 3, which is nothing but equals to 2. So 5 by 3 is more than 1 but less than 2. So what we will do is we will count the number of places we want to jump. We have to jump 5 times. So 1, 2, 3, 4, and 5. So this is the position we will land on it. Okay. So if this is improper fraction, we will do like this, and we can convert this 5 by 3 into a mixed fraction, which is equals to 1 over 2 by 3, which is again 5 by 3. So this is one whole part till this place and 2 more parts in the next line. So this will become 5 by 3. Okay. So this is how we represent 5 by 3, which is sitting 2/3 past the number 1. Okay. Now you guys try this. That is, mark 9 by 4 on the number line. Between which two whole numbers does it lie, and what mixed fraction or mixed number it is? The hint is very simple. How many quarters make each whole? And 9 by 4 will be 2 wholes and how many quarters? Okay. So try this and then we will see its solution. Now on the number line, we will mark 9 by 4. So between two whole numbers, between which two whole numbers does it lie, and what mixed number is it? The answer will be 9 by 4 will lie between 2 and 3. Okay, will lie between 2 and 3. It will lie between 2 and 3 because we will jump 9 times from 1. We have created 4 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have reached between 2 and 3. Okay. And how we will represent it into a mixed number? We have moved till 2. So this will become our first part, and rest of the section, which is this area, this will become our second part, that is the proper fraction. So this is the mixed fraction that we get, mixed number that we get, and this is the position. This is the position of the fraction on the number line. Okay. Now next part is that how we can compare two fractions on the number line. So what we will do is we will place both the fractions on the same line, same start and same gaps. Okay, we will keep both fractions on the number line with same starts and same gaps. The one farther to the right is greater and the one which is nearer to 0 is smaller. Okay, so here we are considering like fractions. Okay, like fractions, that is where denominator is equal of for both the fractions. So let's say we have 3 by 8 comma 5 by 8. Okay, so we will have denominator 8, so we will create 8 equal parts: 1 2 3 4 5 6 7 and 8. So we have created 8 equal parts. Then we will mark 3 by 8 which will come here, and 5 by 8 which will come here. Now you can see 5 by 8 is closer to 1 in comparison to 3 by 8. So 5 by 8 is bigger than 3 by 8. 5 by 8 is bigger than 3 by 8, and this follows our rule, normal rule also, that if the denominator is same, then we will check the numerator, and if it is bigger, then it means that it is of big size. Okay, and this is the surest way to see which fraction is larger. Okay, let's do one example on this. Let's suppose we want to see whether 2 by 5 is bigger or 3 by 5 is bigger. So since both are fifths, so we will create 5 equal parts. So we have one equal part, second equal part, third equal part, fourth equal part, and fifth equal part. For 2 by 5, we will jump 2 gaps from 0. So from here to here, and from here to here. And for 3 by 5, we will jump 3 paths. So again, for 3 by 5, we will come here. Now 3 by 5 is closer to 1. You can see this is closer to 1. It means that 3 by 5 is greater than 2 by 5. Okay, because 3 by 5 lies further to the right. If someone asks which is smaller, so the result will be obvious that 2 by 5 is smaller. 2 by 5 is smaller than 3 by 5. Okay, let's do one quick example, one more example for you guys. What you have to do is you have to use a number line and you have to decide which is greater, 1 by 4 or 3 by 4. That is, which is closer to 0. The hint is closer to 0 means smaller and further towards 1 is bigger. Okay, so let's try it yourself and then we will see its solution. So since both 1 by 4 and 3 by 4 are like fractions, it means that we will create 4 equal parts, because in denominator we have 4 equal parts. So we will create 4 equal parts on the number line. We have 4 equal parts on the number line. Then for 1 by 4 we will jump 1 time, and for 3 by 4 we will jump 3 times. Okay, and now we can see that 3 by 4 is more closer to 1 in comparison to 1 by 4. It means that 3 by 4 is greater than 1 by 4. Okay, or you can say that 1 by 4 is closer to 0. So if someone's asked you which is the smaller one is 1 by 4 and greater one is, this is smaller and this is greater. Okay, so let's do a quick revision on topic 3, that is how we place fractions on the number line. We have seen how we can place proper fractions. We have seen how we can place improper fractions. we have to extend past 1, and we have to keep equal gaps in every whole. Then for mixed fraction and improper fraction comes at the same point. Okay, and every gap in the whole must be of same size. That is, we have to create equal parts of it, then only the concept of fraction will be working in nature. We can compare two fractions. Okay, if they are like fractions, we can compare two fractions. Later on we will see like how to compare unlike fractions also, and if any fraction is closer to 0, it means that it is a smaller fraction. Okay, thank you.